Dividing in scientific notation is basically the same thing as multiplying in scientific notation, except you are going to subtract the powers of 10 instead of adding. So let's have a look at it. 4.38 times 10 to the 4th divided by 2 times 10 to the 12th. First thing I'm going to do is I'm going to just regroup this a little bit, and I'm going to divide 4.38 divided by 2. And now this is a tricky part right here. I'm still going to multiply times 10 to the whatever power, but I'm just regrouping my tens. And I'll show you a fraction format in just a sec that'll help you see it better. So I'm going to regroup the tens together, and 10 to the 4th divided by 10 to the 12th. So what you wind up doing is 4.38 divided by 2, which is 2.19, I believe. And then times 10 to the 4 minus 12. When you divide 10 powers of 10, you're going to subtract the first exponent minus the second exponent. So that's going to give you an answer of 2.19 times 10 to the negative 8th power. Okay, let's look at that as a fraction for just a sec. If I start this thing all over again, 4.38 times 10 to the 4th power divided by 2 times 10 to the 12th power. It's a little bit easier to see that you need to keep the powers of 10 multiplied times the other part. So I can regroup this and just do this fraction, and that's 4.38 divided by 2, which is 2.19, but I'm still multiplying times another fraction, this fraction here. So times 10 to the 4th minus 12th, okay, or 10 to the 4 minus 12. So that helps you see that you're supposed to be keeping that times sign in between these, because you can treat this as one fraction times this other fraction. All right, let's look at another problem. This one is going to have an added twist. So first of all, I think I'm just going to put this in fraction form. 5.9 times 10 to the 16th power divided by 9.5 times 10 to the 5th power. Now, I put this one in brackets or parentheses. That is implied, but it's not always shown. So what I'm going to do is I'm going to regroup this and treat it as two fractions. So 5.9 divided by 9.5 is going to give me a number less than 1. 5.9 divided by 9.5 is 0.62, and I'll just leave the rest of that off. 0.62. Now my other fraction here, 10 to the 16th divided by 10 to the 5th, is still being multiplied times the first fraction, so I'll keep a multiplication sign in between them. So 10 to the 16th divided by 10 to the 5th is the same as 10 to the 16 minus 5. So that's going to be 0.62 times 10 to the 11th power. Now, is this proper scientific notation? The answer is no, because in proper scientific notation, we want one significant figure in front of the decimal and everything else after the decimal. This 0 is not a significant figure because zeros in front of everything else are never significant. So we need this format to look like this. 6.2 times something that will represent 0.62. What will represent 0.62? 6.2 times 10 to the what power? The negative 1 power, because 10 times 6.2 times 10 to the negative 1 would move that decimal one place to the left, and that's what I'm trying to show. So I'm going to reformat this to make it scientific notation, I'm going to show 0.62 as 6.2 times 10 to the negative 1, and then I'll bring the rest of my powers of 10 down, and I'll recombine my powers of 10 here into 6.2 times. Now here I'm multiplying powers of 10. So I'm going to add this exponent and this exponent, and that's 10 to the negative 1 plus 11, which is 6.2 times 10 to the 10th. So that's my final answer here. I hope this has been helpful. If you don't quite understand, then go back and replay the video, pause it before I start working it out, and then try working it yourself and see if you can understand why I did what I did, and see if you do the same thing as I do as you start the video, and even stop it again and go back and replay it again as needed. I'll see you later.